Welcome to our channel.
Today we will tell you about Archimedes in detail. Stay tuned. Archimedes of Syracuse 287 BC, circa 212 BC was an ancient Greek mathematician, physicist, engineer, inventor, and astronomer.
Although few details of his life are known, he is regarded as one of the leading scientists in classical antiquity.
Generally considered the greatest mathematician of antiquity and one of the greatest of all time, Archimedes anticipated modern calculus and analysis by applying concepts of infinitesimals and the method of exhaustion to derive and rigorously prove a range of geometrical theorems, including the area of a circle, the surface area and volume of a sphere, and the area under a parabola. Other mathematical achievements include deriving an accurate approximation of pi, defining and investigating the spiral bearing his name, and creating a system using exponentiation for expressing very large numbers.
He was also one of the first to apply mathematics to physical phenomena, founding hydrostatics and statics, including an explanation of the principle of the lever.
He is credited with designing innovative machines, such as his screw pump, compound pulleys, and defensive war machines to protect his native Syracuse from invasion.
Archimedes died during the siege of Syracuse when he was killed by a Roman soldier despite orders that he should not be harmed. Cicero describes visiting the tomb of Archimedes, which was surmounted by a sphere and a cylinder, which Archimedes had requested to be placed on his tomb, representing his mathematical discoveries. Unlike his inventions, the mathematical writings of Archimedes were little known in antiquity. Mathematicians from Alexandria read and quoted him, but the first comprehensive compilation was not made until c.
530 AD by Isidore of Miletus in Byzantine Constantinople, while commentaries on the works of Archimedes written by Eutychius in the 6th century AD opened them to wider readership for the first time. The relatively few copies of Archimedes' written work that survived through the Middle Ages were an influential source of ideas for scientists during the Renaissance, while the discovery in 1906 of previously unknown works by Archimedes in the Archimedes palimpsest has provided new insights into how he obtained mathematical results. Other discoveries and inventions. While Archimedes did not invent the lever, he gave an explanation of the principle involved in his work on the equilibrium of planes. Earlier descriptions of the lever are found in the peripatetic school of the followers of Aristotle, and are sometimes attributed to Archytas. According to Pappus of Alexandria, Archimedes' work on levers caused him to remark, "Give me a place to stand on, and I will move the earth." Plutarch describes how Archimedes designed block and tackle pulley systems, allowing sailors to use the principle of leverage to lift objects that would otherwise have been too heavy to move. Archimedes has also been credited with improving the power and accuracy of the catapult, and with inventing the odometer during the First Punic War. The odometer was described as a cart with a gear mechanism that dropped a ball into a container after each mile traveled. Cicero 106–43 BC mentions Archimedes briefly in his Dialogue de Re Publica, which portrays a fictional conversation taking place in 129 BC. After the capture of Syracuse c. 212 BC, General Marcus Claudius Marcellus is said to have taken back to Rome two mechanisms, constructed by Archimedes and used as aids in astronomy, which showed the motion of the Sun, Moon and 5 planets. Cicero mentions similar mechanisms designed by Thales of Miletus and Eudoxus of Cnidus. The dialogue says that Marcellus kept one of the devices as his only personal loot from Syracuse, and donated the other to the Temple of Virtue in Rome. Marcellus' mechanism was demonstrated, according to Cicero, by Gaius Sulpicius Gallus to Lucius Furius Philus, who described it thus. Hanc sphaerum Gallus cum moveret, fibat ut soli luna totitum conversionibus in aer illo quat debus in ipso calo succederet, ex quo et in calo sphera solis ferit idem illa defectio, et insideret luna tum in metam quae esset umbra terrae, cum sol regium. When Gallus moved the globe, it happened that the moon followed the sun by as many turns on that bronze contrivance as in the sky itself, from which also in the sky the sun's globe became to have that same eclipse, and the moon came then to that position which was its shadow on the earth, when the sun was in line. This is a description of a planetarium or orrery. Pappus of Alexandria stated that Archimedes had written a manuscript on the construction of these mechanisms entitled On Sphere Making. Modern research in this area has been focused on the Antikythera mechanism, another device built circa 100 BC that was probably designed for the same purpose. Constructing mechanisms of this kind would have required a sophisticated knowledge of differential gearing. This was once thought to have been beyond the range of the technology available in ancient times, but the discovery of the Antikythera mechanism in 1902 has confirmed that devices of this kind were known to the ancient Greeks. Mathematics. While he is often regarded as a designer of mechanical devices, Archimedes also made contributions to the field of mathematics. Plutarch wrote, "He placed his whole affection and ambition in those purer speculations where there can be no reference to the vulgar needs of life." Archimedes was able to use infinitesimals in a way that is similar to modern integral calculus. Through proof by contradiction, reductio ad absurdum, he could give answers to problems to an arbitrary degree of accuracy, while specifying the limits within which the answer lay. This technique is known as the method of exhaustion, and he employed it to approximate the value of pi. In measurement of a circle he did this by drawing a larger regular hexagon outside a circle and a smaller regular hexagon inside the circle, and progressively doubling the number of sides of each regular polygon, calculating the length of a side of each polygon at each step. As the number of sides increases, it becomes a more accurate approximation of a circle. After 4 such steps, when the polygons had 96 sides each, he was able to determine that the value of pi lay between 31/7, approximately 3.1429, and 310/71, approximately 3.1408, consistent with its actual value of approximately 3.1416. He also proved that the area of a circle was equal to pi multiplied by the square of the radius of the circle pi r2. In On the Sphere and Cylinder, Archimedes postulates that any magnitude when added to itself enough times will exceed any given magnitude. This is the Archimedean property of real numbers. In measurement of a circle, Archimedes gives the value of the square root of 3 as lying between 265 153, approximately 1.7320261, and 1351 780, approximately 1.7320512. The actual value is approximately 1.7320508, making this a very accurate estimate. He introduced this result without offering any explanation of how he had obtained it. This aspect of the work of Archimedes caused John Wallis to remark that he was, as it were, of set purpose to have covered up the traces of his investigation, as if he had grudged posterity the secret of his method of inquiry while he wished to extort from them assent to his results. It is possible that he used an iterative procedure to calculate these values. In the quadrature of the parabola, Archimedes proved that the area enclosed by a parabola in a straight line is 4/3 times the area of a corresponding inscribed triangle as shown in the figure at right. He expressed the solution to the problem as an infinite geometric series with the common ratio 1/4. N equals 0 infinity 4 minus n equals 1 plus 4 minus 1 plus 4 minus 2 plus 4 minus 3 plus equals 4 3. Display style sum underscore n equals 0 caret inft 4 caret n equals 1 plus 4 caret minus 1 plus 4 caret minus 2 plus 4 caret minus 3 plus c dots equals 4 over 3 sum underscore n equals 0 caret inft 4 caret n equals 1 plus 4 caret minus 1 plus 4 caret minus 2 plus 4 caret minus 3 plus c dots equals 4 over 3. If the first term in this series is the area of the triangle, then the second is the sum of the areas of two triangles whose bases are the two smaller secant lines, and so on. This proof uses a variation of the series 1/4 plus 1/16 plus 1/64 plus 1/256 plus which sums to 1/3. In the Sand Reckoner, Archimedes set out to calculate the number of grains of sand that the universe could contain. In doing so, he challenged the notion that the number of grains of sand was too large to be counted. He wrote, "There are some, King Gello II, son of Hiero II, who think that the number of the sand is infinite in multitude, and I mean by the sand not only that which exists about Syracuse and the rest of Sicily but also that which is found in every region whether inhabited or uninhabited." To solve the problem, Archimedes devised a system of counting based on the myriad. The word is from the Greek myrias myrias, for the number 10,000. He proposed a number system using powers of a myriad of myriads 100 million, and concluded that the number of grains of sand required to fill the universe would be 8 vigintillion, or 8 times 1063. Writings. The works of Archimedes were written in Doric Greek, the dialect of ancient Syracuse. The written work of Archimedes has not survived as well as that of Euclid, and 7 of his treatises are known to have existed only through references made to them by other authors. Pappus of Alexandria mentions on sphere making in another work on polyhedra, while Theon of Alexandria quotes a remark about refraction from the now lost Catoptrica. During his lifetime, Archimedes made his work known through correspondence with the mathematicians in Alexandria. The writings of Archimedes were first collected by the Byzantine Greek architect Isidore of Miletus c. 530 AD, while commentaries on the works of Archimedes written by Eutychius in the 6th century AD helped to bring his work a wider audience. Archimedes' work was translated into Arabic by Thabit ibn Qurra, 836–901 AD, and Latin by Gerard of Cremona, c. 1114–1187 AD. During the Renaissance, the Editio Princeps, first edition, was published in Basel in 1544 by Johann Herwagen with the works of Archimedes in Greek and Latin. Around the year 1586 Galileo Galilei invented a hydrostatic balance for weighing metals in air and water after apparently being inspired by the work of Archimedes. Surviving works. On the Equilibrium of Planes, 2 volumes. The first book is in 15 propositions with 7 postulates, while the second book is in 10 propositions. In this work Archimedes explains the law of the lever, stating, magnitudes are in equilibrium at distances reciprocally proportional to their weights. Archimedes uses the principles derived to calculate the areas and centers of gravity of various geometric figures including triangles, parallelograms and parabolas. On the measurement of a circle. This is a short work consisting of 3 propositions. It is written in the form of a correspondence with Dositheus of Pelusium, who was a student of Conon of Samos. In proposition 2, Archimedes gives an approximation of the value of pi, showing that it is greater than 223/71 and less than 22/7. On spirals. This work of 28 propositions is also addressed to Dositheus. The treatise defines what is now called the Archimedean spiral. It is the locus of points corresponding to the locations over time of a point moving away from a fixed point with a constant speed along a line which rotates with constant angular velocity. Equivalently, in polar coordinates r, theta, it can be described by the equation r equals a plus b theta, displaystyle r equals a plus b theta, r equals a plus b theta. With real numbers a and b. This is an early example of a mechanical curve, a curve traced by a moving point considered by a Greek mathematician. On the Sphere and the Cylinder, 2 volumes. In this treatise addressed to Dositheus, Archimedes obtains the result of which he was most proud, namely the relationship between a sphere and a circumscribed cylinder of the same height and diameter. The volume is 4/3 pi r3 for the sphere, and 2 pi r3 for the cylinder. The surface area is 4 pi r2 for the sphere, and 6 pi r2 for the cylinder, including its 2 bases where r is the radius of the sphere and cylinder. The sphere has a volume 2/3 that of the circumscribed cylinder. Similarly, the sphere has an area 2/3 that of the cylinder, including the bases. A sculpted sphere and cylinder were placed on the tomb of Archimedes at his request. This is a work in 32 propositions addressed to Dositheus. In this treatise Archimedes calculates the areas and volumes of sections of cones, spheres, and paraboloids. On floating bodies, 2 volumes. In the first part of this treatise, Archimedes spells out the law of equilibrium of fluids, and proves that water will adopt a spherical form around a center of gravity. This may have been an attempt at explaining the theory of contemporary Greek astronomers such as Eratosthenes that the Earth is round. The fluids described by Archimedes are not self-gravitating, since he assumes the existence of a point towards which all things fall in order to derive the spherical shape. In the second part, he calculates the equilibrium positions of sections of paraboloids. This was probably an idealization of the shapes of ships' hulls. Some of his sections float with the base under water and the summit above water, similar to the way that icebergs float. Archimedes' principle of buoyancy is given in the work, stated as follows. Any body wholly or partially immersed in a fluid experiences an upthrust equal to, but opposite in sense to, the weight of the fluid displaced. The quadrature of the parabola. In this work of 24 propositions addressed to Dositheus, Archimedes proves by 2 methods that the area enclosed by a parabola and a straight line is 4/3 multiplied by the area of a triangle with equal base and height. He achieves this by calculating the value of a geometric series that sums to infinity with the ratio 1/4. Stomation. This is a dissection puzzle similar to a tangram, and the treatise describing it was found in more complete form in the Archimedes palimpsest. Archimedes calculates the areas of the 14 pieces which can be assembled to form a square. Research published by Dr. Raviel Netz of Stanford University in 2003 argued that Archimedes was attempting to determine how many ways the pieces could be assembled into the shape of a square. Dr. Netz calculates that the pieces can be made into a square 17,152 ways. The number of arrangements is 536 when solutions that are equivalent by rotation and reflection have been excluded. The puzzle represents an example of an early problem in combinatorics. The origin of the puzzle's name is unclear, and it has been suggested that it is taken from the ancient Greek word for throat or gullet, stomachos. Ausonius refers to the puzzle as ostomachon, a Greek compound word formed from the roots of ostion, bone and match fight. The puzzle is also known as the loculus of Archimedes or Archimedes' box. Archimedes' cattle problem. This work was discovered by Gotthold Ephraim Lessing in a Greek manuscript consisting of a poem of 44 lines, in the Herzog August Library in Wolfenbüttel, Germany in 1773. It is addressed to Eratosthenes and the mathematicians in Alexandria. Archimedes challenges them to count the numbers of cattle in the herd of the sun by solving a number of simultaneous Diophantine equations. There is a more difficult version of the problem in which some of the answers are required to be square numbers. This version of the problem was first solved by Amthor in 1880, and the answer is a very large number, approximately 7.760271 times 10,206,544. The sand reckoner. In this treatise, Archimedes counts the number of grains of sand that will fit inside the universe. This book mentions the heliocentric theory of the solar system proposed by Aristarchus of Samos, as well as contemporary ideas about the size of the Earth and the distance between various celestial bodies. By using a system of numbers based on powers of the myriad, Archimedes concludes that the number of grains of sand required to fill the universe is 8 times 10^63 in modern notation. The introductory letter states that Archimedes' father was an astronomer named Phidias. The Sand Reckoner or Sonnets is the only surviving work in which Archimedes discusses his views on astronomy. The method of mechanical theorems. This treatise was thought lost until the discovery of the Archimedes palimpsest in 1906. In this work Archimedes uses infinitesimals, and shows how breaking up a figure into an infinite number of infinitely small parts can be used to determine its area or volume. Archimedes may have considered this method lacking in formal rigor, so he also used the method of exhaustion to derive the results. As with the cattle problem, the method of mechanical theorems was written in the form of a letter to Eratosthenes in Alexandria. Apocryphal works. Archimedes, Book of Lemmas or Liber Assumptorum is a treatise with 15 propositions on the nature of circles. The earliest known copy of the text is in Arabic. The scholars T. L. Heath and Marshall Clagett argued that it cannot have been written by Archimedes in its current form, since it quotes Archimedes, suggesting modification by another author. The lemmas may be based on an earlier work by Archimedes that is now lost. It has also been claimed that Heron's formula for calculating the area of a triangle from the length of its sides was known to Archimedes. However, the first reliable reference to the formula is given by Heron of Alexandria in the 1st century AD. Archimedes' palimpsest. The foremost document containing the work of Archimedes is the Archimedes palimpsest. In 1906, the Danish professor Johann Ludvig Heiberg visited Constantinople and examined a 174-page goatskin parchment of prayers written in the 13th century AD. He discovered that it was a palimpsest, a document with text that had been written over an erased older work. Palimpsests were created by scraping the ink from existing works and reusing them, which was a common practice in the Middle Ages as vellum was expensive. The older works in the palimpsest were identified by scholars as 10th century AD copies of previously unknown treatises by Archimedes. The parchment spent hundreds of years in a monastery library in Constantinople before being sold to a private collector in the 1920s. On October 29, 1998, it was sold at auction to an anonymous buyer for $2 million at Christie's in New York. The palimpsest holds 7 treatises, including the only surviving copy of On Floating Bodies in the original Greek. It is the only known source of the method of mechanical theorems, referred to by Suidas and thought to have been lost forever. Stomation was also discovered in the palimpsest, with a more complete analysis of the puzzle than had been found in previous texts. The palimpsest is now stored at the Walters Art Museum in Baltimore, Maryland, where it has been subjected to a range of modern tests including the use of ultraviolet and X-ray light to read the overwritten text. The treatises in the Archimedes palimpsest are On the Equilibrium of Planes, On Spirals, Measurement of a Circle, On the Sphere and the Cylinder, On Floating Bodies, The Method of Mechanical Theorems and Stomation. Legacy. Galileo praised Archimedes many times, and referred to him as a superhuman. Leibniz said, "He who understands Archimedes and Apollonius will admire less the achievements of the foremost men of later times." There is a crater on the Moon named Archimedes 29.7 degrees north, 4.0 degrees west, in his honor, as well as a lunar mountain range, the Montes Archimedes 25.3 degrees north, 4.6 degrees west. The Fields Medal for Outstanding Achievement in Mathematics carries a portrait of Archimedes, along with a carving illustrating his proof on the sphere and the cylinder. The inscription around the head of Archimedes is a quote attributed to him which reads in Latin, Transire suum pectus mundo, podere, rise above oneself and grasp the world. Archimedes has appeared on postage stamps issued by East Germany 1973, Greece 1983, Italy 1983, Nicaragua 1971, San Marino 1982, and Spain 1963. The exclamation of Eureka, attributed to Archimedes, is the state motto of California. In this instance the word refers to the discovery of gold near Sutter's Mill in 1848 which sparked the California Gold Rush. Thank you.